If we look at the graph of y equals x to the negative 2, well, first we make a table. Negative 2 to the negative 2 is 1 over negative 2 squared, which of course is just 1/4. When we square the number in the denominator, we're going to take care of that negative sign. It's going to be positive. And 1 over negative 1 squared is clearly 1 over 1, which is 1. 1 over 0 squared is still going to be 1 over 0. That's undefined. 1 over 1 squared is 1. 1 over 2 squared, of course, is 1/4. So when we do the table, we get a graph that's somewhat steeper than the other. It still has the same behavior. As we approach 0, we get larger and larger and larger numbers because, of course, we're dividing by the number we have over here, the number that approaches 0. We're dividing 1 by that number, and then we're squaring it. So it gets big, and it gets big even faster than before. The main thing we note about this graph is that it's symmetric about x equals 0. The results we get on this side are the same as the results we get on this side. We say that the graph and the table are both symmetric. We see that the graph is the same here as it is here. That is, this is a reflection of this. Each is a reflection of the other, even though I haven't drawn it completely accurately. You understand the principle here. That's generally true of even-powered functions. Okay, the function y equals x squared, x to the 4th, x to the 6th, x to the negative 2, x to the negative 4, x to the negative 6. Any even-powered function is going to square out the negative, and we're going to have this kind of symmetry. If, on the other hand, we have an odd-powered function, we're going to have an anti-symmetry. We might have a graph, as we did before, recall, that looks like this. Okay, like the 1 over x. So that this is called anti-symmetry, where we have the negative on this side and the positive on this side. It's kind of a negative reflection. There's a little more to it than just reflection if you want to get technical, but you understand the idea.